Hi, my name is John Perry with IPC, here with the technical question of the week. One of the questions we frequently get from members in our industry is what rules of thumb or what guidance does IPC provide in our standards for the clearance between components that are placed on the surface of a circuit board. We actually have three standards that provides that information. The first is our soldering specification, J standard 001. That will then take us to the second standard, which is our generic standard on printed board design, IPC 2221. And lastly will be referenced to the IPC 7351, which is a standard that provides land pattern recommendations for placement of the component on the printed board. J standard 001 defines electrical clearance as the minimum spacing between non-common, uninsulated conductors. Throughout J standard 001, requirements for electrical clearance are typically referred to voltage spacing clearances that are actually provided in the IPC 2221 design standard. A good example of this is in the illustrations that J standard 001 provides for overhang of surface mount lead terminations. In this visual example of gull-wing lead terminations from surface mount parts, J standard 001 provides requirements for the side overhang as well as the toe overhang of parts. And within this document, references are given to maintaining minimum electrical clearances for the side and the toe overhang of those lead termination devices. This is an example of Table 6-1 from the IPC 221 design standard, which provides minimum spacing between conductive patterns, both internal and external conductors on the bare board, as well as lead terminations on the finished printed board assembly. It provides these electrical clearances based on the voltage between conductors. J standard 001 will typically references this table within IPC 221 for minimum electrical clearance between lead terminations. Finally, we have the IPC 7351 standard for surface mount land pattern designs. One of the key things that this standard provides is something called a courtyard boundary. The courtyard is a combination of the placement of the surface part, including its lead termination, plus the land pattern for placing the part on the surface of the printed board. In addition, it also includes what's called a courtyard excess. The courtyard excess actually incorporates the minimum electrical clearance values described in IPC 2221. In addition, the courtyard also includes a manufacturing allowance zone. This manufacturing allowance zone basically incorporates tolerances in the fabrication of the printed board, such as registration. Altogether, this provides a maximum courtyard, and the concept with IPC 7351 is you can take two courtyards and place them side by side such that the spacing between the courtyard boundaries are zero, and you will be assured that you have provided both minimum electrical and mechanical clearance between the adjacent components, sufficient enough for most pick-and-place machinery. Lastly, the 7351 provides three separate land pattern geometries. So the standard actually has a tool in it with which you can reduce or expand the size of the courtyard excess and the manufacturing zone based on your printed board density. For example, if you're placing parts on a small form factor board, that will allow you to reduce the size of this overall boundary. Even with the smallest possible boundary that the 7351 provides, by placing it up against the boundary for another courtyard, you're still assured that you will place two components with sufficient space for pick-and-place machinery. Thank you.